welcome back everyone. I hope you guys are doing really well. My name is Julian and today we will try to dive a little more deeper with creating databases and setting up their constraints. But before we can learn more about it, I want to share a story. I want to share a personal experience that I had when I was learning databases. So when I initially started learning databases, I created a database within a company. But as soon as the company started to grow the project with different types of entries, different type of data values in it, my database started running into data integrity issues and data consistency issues. So data consistency and data integrity is one of those terms which would be used a lot of times in the discussion. So let's try to understand what data integrity actually means and what data consistency means. So basically data integrity means that the data that we have in the database, it is true and it is reliable. So basically whatever entries that we have inside the database, it makes sense. And also if there's any relation that we are trying to store inside the database, it is also true. And the second thing, which is the consistency. So consistency basically means that the different entries that we have entered inside the database, it is consistent and it is storing the data in the right format. So as the project grew, the problem for data integrity and data consistency was harder to handle. That's where I realized the use case of having correct constraints whenever you're setting up the table inside the database. So this actually helped me solve a lot of issues and made everything run smoothly. So let me share a few examples of the problem that I faced and how constraints were able to help me to fix them. So the first problem that I faced was the missing data. So while designing the database for student management system, I was adding records for students. One day I realized that some of the students' last name were missing. And in some cases, the first names were left blank. This led to incomplete records in my database, which created confusions and issues later when generating reports or performing analysis on them. To solve this, I came across a constraint which was called NOT NULL. So NOT NULL constraint made sure that the fields like first name or last name could not be left empty. With this change, I could ensure that every student had a complete name before the record was inserted into the database. So for making use of this NOT NULL constraint, we can use this keyword right next to the field name. So in the database that we have created, all right, so let's just say this is a table that we are trying to create. So for making sure that the user is not able to enter any incomplete entries for this table, let's make use of the not null constraint right next to the data type, so that if there is any entry which is incomplete for first name or last name, it will give us an error. This keyword in simple terms means that values for the field name, first name and last name cannot be null at any given time. So by enforcing the not null constraint, I ensured that no record was incomplete. It eliminated the problem of students having missing details and improved the overall data quality in my project. So one more problem that I noticed was that as students added values inside the database, so I started noticing that there were some duplicate records. There were multiple entries inside the database with the same student ID. But we know that whenever a student is enrolled in a school, two students cannot have similar ID. One error that was present in the tables. And it was causing a lot of confusions when we were trying to retrieve information from the table and also when we were trying to generate reports. The solution was very simple. So I made use of the constraint primary key. So the primary key constraint makes sure that whatever values that we want to have for that particular field is always unique. So this prevented from any duplicate entries to be entered inside the database. So for making use of this keyword primary key, we add the constraint primary key right next to the data type. So in this table that we are trying to create, we want to make sure that every entry inside this table is unique and there is no redundant data that is present inside this table. So we can make use of the constraint primary key right next to the data type of student ID, which is integer, so that if any two users tries to enter similar ID, it will throw us an error. It will give us an error. All right, so by making use of primary key, I ensured that no two students could have the similar student ID, which helped me eliminate student records and kept the data much more organized and consistent. I also ran into a situation where some of the students were assigned to a class that didn't even exist in the system. So this was particularly problematic because as the project grew, it became increasingly difficult to track where each student belonged. So without enforcing valid relationship between tables, I ended up with student assigned to non-existent classes. So to fix this, I made use of the keyword foreign key. So the foreign key constraint helped me link the students with the classes table. So the classes ID in the student table was referred to the classes ID in the classes table, ensuring that if there is any entry which is invalid, it cannot be assigned to students. All right, so let's take a look at how we can do it. So let's say we are having two tables here. All right, so let's just say we are trying to create two tables called class and student inside the database. So for class ID, this class ID basically refers to the class ID that we have inside the table class. But let's just say the user is entering class ID over here in this table, which is not valid. So we want to make sure that whatever entries that this particular class ID has, it is always a valid entry inside the table class. We will make use of the foreign key. So for setting up the foreign key, we will make use of the keyword foreign key. And then we will choose the name of the column class ID. And then we will make a reference to the table that we want to connect it to. So we want to connect it to the table class. And then the class ID should be linked to the class ID of the table class. So by doing this, any entry that we are trying to set for class ID, it will be unique and it will also be valid. Also try to make sure that whenever we are trying to create a connection using foreign key, so the reference that we are trying to create for the other table called class, the ID that we are specifying for the other table should always be a primary key so that it can be uniquely identified. All right. So we are done with creating a table. Let's try to refresh this and we can see that we are done with creating two tables. Okay, so looking back at these challenges, I realized how essential SQL constraints were in maintaining the integrity of my project. Without constraints like not null, primary key, and foreign key, I would have spent a lot of time dealing with incomplete, duplicate, or invalid entries in the database. Making use of constraints, I was able to handle a lot of problems that I was running into while creating tables. And it also helped me save a lot of my time, which was spent cleaning the table and troubleshooting the table because of redundant entries and invalid data. Okay, I hope you had a good time learning more about constraints. Thank you for joining, everyone. Happy coding.